Find the absolute max and min of the cube root of x on the interval from -1 to 1. When you're doing absolute extrema, you need to find your critical numbers, and then you test your what and your what. Critical numbers and your endpoints by plugging them in where? Original function, right? Is there a because statement for absolute extrema? No, please don't write one, because you will get it wrong. Okay. The other thing I need to point out that I did not take off on this quiz, but I 100% will take off on your test. What is the name of this function? G. So if you're writing F everywhere in your work, I will take off. All right. So, and not only am I saying I'll take off, like if you think I'm bluffing, you know those little scoring guidelines, right? We have it in there, like -1 if the student uses, F instead of G or Q or whatever we call the function. So make sure you call it like you pay attention to function names and you call it by whatever it's called. All right, so absolute min. So first thing we got to do is find our critical numbers. So this is x to the 1/3, so we get 1/3 x to the -2/3, or 1/3 times the cube root of x squared. So the derivative is never 0. Does that mean there's no critical numbers? Okay, critical numbers are where the derivative is 0 or undefined, right? So the derivative is undefined at x equals 0. We have a critical number at x equals 0. So now we're going to test. So g of -1, g of 0, g of 1. I'm going to go bottom up. Cube root of 1 is 1. Cube root of 0 is 0. I had maybe 1 in 10 students tell me that the cube root of -1 is undefined. Is the cube root of -1 undefined? What's cube root of -1? -1. Cube root is never undefined, right? You can have a cube root of a negative. You can't have a square root of a negative, but you can have any odd root of any number, right? It's the even roots that cause you problems. So the cube root of -1 is -1. All right, so now I write, what is my min? -1. Is that an x value? Do I write as an x value or y value in ordered pair? What do I write? Just the y value. Okay, those of you who are writing, I didn't take off. I scratched off. I was annoyed, but I didn't take off. You don't want to annoy the person who's grading your paper, right? Okay, absolute extrema are y values. That's it, y values. So your min is -1. Your max is 1. You are done. This is fully justified. You're done. All right, so critical numbers. Okay, let's turn it off. That's a good alarm.
Yeah, someone was doing the find my phone thing.
Oh. Okay. All right. Okay, any questions on number 1? So find your critical numbers, test your critical numbers and your endpoints by plugging them into the original function. Biggest is your max, smallest is your min, kabam, right? Okay. And then there was this one. I was actually quite pleased. Most of you did pretty well on this one. Please don't make up your own because statements. Just write the ones like you really do. If you haven't memorized them, you need to memorize them. But write the because statements that you've been taught verbatim and just go with it. All right. So I'm going to do this problem, the first section, without making a sign line. I actually think when you have a graph with derivative, it's easier to answer the questions without a sign line than with a sign line. This is a change of heart. 10 years ago, I would have said make your sign line and use your sign line. But in the last 10 years, I have grown to enjoy doing these without sign lines, and then I just use my sign line to graph. But if you want to make a sign line, it's totally fine. Okay, whatever you want to do. So, first question, so this is the graph of f prime. F prime, right? Not f. This is f prime. So we want to know where f has a horizontal tangent. How do we know when a function has a horizontal tangent? When the slope is 0, right? So we're looking for where f prime equals 0. Where does f prime equal 0? -1, 4, and 6. So we have a horizontal tangent line at x equals -1, 4, and 6 because f prime of -1, f prime, I should just say f prime equals 0 at those values. It'd just be easier. F prime of x equals 0 at these values. Now, if you're looking at my screen at this, I have more space than you do. So that is because I realized while I was grading that I did not give you guys enough space. So next year everybody gets extra space. So sorry, you guys got the little space, but anyway. Same problems, just more space. All right, we want to know where f is increasing. Think because statement. F is increasing on some interval because f prime is greater than 0. We're looking for where f prime is greater than 0. F prime is literally greater than 0 means f prime is positive. It means where is f prime above the x-axis, right? So f prime is positive on what intervals? -1 to 4 and 6 to infinity because f prime is greater than 0 on those intervals. So literally above the x-axis means f prime is positive when it's positive, negative when it's negative. Don't confuse positive with, don't try to interpret increasing, decreasing. This is f prime. We want to know when f prime is positive. If you pick an x and plug it in and get a positive number, it's positive. All right, x values where f has a relative max. So a relative max occurs at some ordered pair because, is that our because statement? The signs change. Would I accept that? F of x changes? F prime of x changes from positive to negative, right? F prime changes from positive to negative. What is the only x value where f prime changes from positive to negative? 4, where it was above the x-axis and then it's below the x-axis. That's our relative max. Do you understand that? Okay. By the way, notice they only asked you for x values, so don't give ordered pairs when you're not asked for ordered pairs. Again, I didn't take off, but be careful because if you put an ordered pair, it better be correct. So I would watch out with that. Just answer what's asked. Find the x value where f has a relative max. So a relative max occurs at, I'm already starting out in ordered pair mode. At x equals 4 because f prime of x changes from positive to negative at x equals 4. How are we doing? Talk to me if you have questions. You doing okay? Yeah. Okay. All right. Is f increasing or decreasing at x equals 5? So we're talking about, is f prime positive or negative at x equals 5? At x equals 5, which is right here, is f prime positive or negative? It's negative. So f is increasing. Oh, whoops, I just said the opposite. It's negative. Maybe I should re-record next period. Decreasing because f prime of 5 is negative. All right. State the intervals where f is concave down. So now, how do we know when f is concave down? There's 2 ways we know. What's one way? F double prime is negative. How do we know when f double prime is negative? When f prime is decreasing, right? So this function f of x is concave down whenever f prime is decreasing, f prime is decreasing from here to here, so 2 to 5. So you would say 2 to 5 because I would love for you to say f prime is decreasing on 2 to 5. If you write f double prime as negative, I took it. So I would put or f double prime is negative on 2 to 5. I will tell you the College Board, when you're not given f double prime or an actual function where you can find f double prime, if you're just given f prime, they prefer that you write your justifications in terms of f prime. So I would get in the habit, if you're doing concavity from a graph of f prime, to write because f prime is decreasing or f prime is increasing. But if you write f double prime as negative, it's true and it justifies. So unless they like specifically ask, they would accept it. It's just they would prefer the f prime. All right, any questions on any of that? All right, let's make some sign lines, and then we're going to make a big F sign line. So we know, I'm going to make the sign lines up here first. I'm going to make a quick F prime sign line. Oh, whoops, this is not a closed, this is an open, negative infinity to infinity. So if you're making an F prime sign line, the critical numbers you put on your sign line are literally where F prime is 0 or undefined. It's never undefined, so f prime is 0 at -1, 4, and 6. So you'd have a -1, 4, and a 6. And then your signs are literally the signs of f prime. It's negative, it's positive, it's negative, it's positive. So your function is decreasing, increasing, decreasing, increasing. All right. Then if we make an f double prime sign line, the critical numbers for f double prime are the maxes and mins for f prime. It's where f prime changes direction from increasing to decreasing or decreasing to increasing, which would be at 2 and 5. So we are increasing, so f double prime is positive, so decreasing means negative, increasing means positive. We're concave up, down, up. So when we make our big F sign line, we need -1, 2, 4, 5, and 6. So I'm going to make down here -1, 2, 4, 5, and 6. This is my big F sign line. Filling in my arrows, decreasing to -1, increasing to 4, decreasing to 6. All right, decreasing, increasing. Oop. Okay. Do it this way. There we go. All right. Now to do my concavity symbols. So I was up to 2, down to 5, up the rest of the way. So up to 2. Up to 2, down to 5, up the rest of the way. All right, so the shape of my function, so decreasing concave up, increasing concave up, increasing concave down, decreasing concave down, decreasing concave up, increasing concave up. Some of you put like one symbol and stretch it across. I really would put a separate symbol in every little section, right? And it helps you connect your graph. All right, so let's go ahead and look at what we were told. F of -1 is 0, and f of 4 is 5. Okay. All right, so that's all we've got. We have no other numbers in between. We do know that it goes from -infinity to infinity. So we're going to go from -infinity to -1. We are decreasing this shape. And then from -1 to 2, so we're going to be increasing all the way to 4. If this is 4, so I'm going to increase and increase. You can stop anywhere in, let's see. So to 2, the y value, we don't know like what y value, but we do know from -1 to 2, we're concave up. And then from 2 to 4, we're concave down. going to try to make this connect a little better. All right, and then from 4 to 5, we're decreasing concave down. And then from 5 to 6, we're decreasing concave up. And then from 6 to infinity, we're increasing concave up. I want this to be a little bit more. There we go. All right, spot. So there's my beautiful graph. The y values here, like this could be just real little, right? Or it could be really long, because we don't know the y values here. We just know the shape. So as long as the shape is correct, we're good. Just so you know, I counted every single blank on this quiz was worth 2 points. So for all of these, it was answer, like point for the answer, point for the because statement. Point for the answer, point for the because statement for every single one of these. For the graph, I did a point for your increasing and decreasing intervals and a point for your concavity. So if you were missing whole sections of the graph, like if you didn't have any graph before -1, I couldn't give you anything because your increasing, decreasing was wrong and your concavity was wrong. So you got a -2. So don't be missing whole sections of your graph. All right. Okay, any questions on this page? This wasn't the part that was difficult for us. For the most part, most students did okay on this part. All right. This one, straight up derivative question, but the second derivative was tricky. I still thought it was fair. I thought that maybe you needed more space, but I thought the question was fair. However, I have been told, strongly suggested that we next year give you the first derivative and the second derivative. I have mixed feelings. I haven't relented to that yet. So anyway, so let's go ahead and do, because I think you guys can all do this derivative, right? So I'm going to rewrite my f of x as 2 times x squared plus x minus 6 to the negative first. So -2 times x squared plus x minus 6 to the negative second times 2x plus 1. So my f prime is -4x minus 2. You know, I should just keep it factored. No, I'm gonna distribute. I'm going back and forth, but -4x minus 2 over x squared plus x minus 6 squared. This bottom factors so this factors into x plus 3x minus 2. So we have critical numbers. So we set the top -4x minus 2 equals 0. So you get x equals -0.5. And we set the bottom, and you get x equals -3 or 2. All right, so we make a sign line. So -3, -1/2, 2. This is our f prime sign line. The bottom of f prime is always what? Bottom of f prime, take a look at it. It's always what? Positive. Because you're squaring it. So why would you even plug numbers into the bottom? It's always positive, right? So I can ignore the bottom when I'm making my sign line and just look at the top, right? So I really should have kept it factored. I don't know why I distributed. Maybe for the next derivative to make it easier. Anyway, so if I look at the top and I plug in a -5, I get a positive, still positive. Then if I plug in like a 0, I get a negative, and a 10, I get a negative. So we are increasing, increasing, decreasing, decreasing. You guys remember when I told you if you have an even multiplicity that the sign's going to be the same on each side of that number, right? So, people are shaking. I did. So odd multiplicity on top means you have, your sign's going to alternate. Even means it'll be the same. All right. Okay, so let's answer the first question. So we are all right, we're decreasing from -1/2 to 2 and 2 to infinity. This is where those of you who ignored my advice lost a point. So we are decreasing from -1/2 to 2, union 2 to infinity, because f prime is less than 0 on those intervals. Now, College Board accepts closed or open, but your teacher has said always use open every single time and always separate at all of the x values on your sign line. Why did you have to separate this at 2? Why couldn't you just go -1/2 to infinity? Because the function doesn't even exist at 2. It can't be decreasing at an x value where it doesn't exist. You can't include the 2. So if you always write your intervals open and exclude all your critical numbers, you'll always be right. If you try to skip that and just kind of do your own thing, you will sometimes be right and sometimes be wrong. So I took off a lot of -1s on this one for people who had -1/2 to infinity. So be careful about that. If you just always write your intervals, you always write them open and just follow your sign line. -1/2 to 2, 2 to infinity, done. Piece of cake. Yes, Mohan. A comma to separate your intervals?
Yeah.
I would accept it, but I'd be annoyed because I know you know union notation, which is proper set notation, right? Okay. All right, relative max. So the only relative max occurs at x equals -1/2. Hey, a relative max is a what? How do we write a relative max? It's an ordered pair. Now, I accepted a y value for this only because I know that WebAssign wants a y value for their relative maxes and mins. So I accepted a y value or an ordered pair, but what I didn't accept was just the x value, right? So you had to actually find the y value. So you have -1/2 comma, and I think it's -81/25. Okay, so you have to plug -1/2 in and you have some fun with fractions. Because f prime changes from positive to negative at this point. All right. Concave down, second derivative. This will be fun. Okay. I'm going to use this guy right here as my first derivative, and I'm going to do a wonderful quotient rule. All right, so drew the top, -4 times the bottom, minus the top times the drew the bottom, which is 2 times x squared plus x minus 6 to the first times 2x plus 1. All over the bottom square. So the first thing I did when I did my derivative was I canceled an x squared plus x minus 6 from every term. So I was left with -4 times x squared plus x minus 6. So I'm going to kill these negatives and put plus, and I'm going to distribute this 2 in here. Let's just kill some stuff. So we have 8x plus 4 times 2x plus 1 over x squared plus x minus 6 cubed. All right, in order to find the zeros at the top, I'm going to have to distribute and combine like terms. -4x squared minus 4x plus 24 plus 16x squared plus 8x plus 8x plus 4. And I can rewrite this as x plus 3 minus 2 cubed. All right, let's combine. So we get 12x squared. So 16 plus 12x plus 28. Are you guys making sure I do my math right? Okay. Okay. Oh, oops, thank you. Cubed. All right. On the top, so you can factor a 4 out, right? If you factor out a 4 or just leave it, either way, I didn't feel guilty about this because I know in WebAssign you've gotten a lot of problems in the last 2 months where you had a quadratic with no solution. So I know that you guys are fairly comfortable with checking your determinants or your discriminants first. So the discriminants of b squared minus 4ac. So b squared, so 144, minus 4 times 12 times 28 is going to be very much negative. There was no solution on top. So your only critical numbers were negative 3 and 2. So we make an f double prime sign line. See, this quiz was easy. I know it was a little challenging. I might go ahead and give everybody these derivatives. I think Ms. Grunwald might be right. Might be too much. Anyway. All right. So, if we pick like a 0, so we get positive on top and we get negative on the bottom. So positive times a negative is a negative. So we are negative, and since we're alternating, we can go like that. So we are concave up, down, up. All right. So what's the question asking? Woo! Concave down? We're concave down from negative 3 to 2. Done. Piece of cake. That was a big one. I know that took a lot of work to get that second derivative. So, anyway. All right, theorems. By the way, let me go back. Were there any? I know it was a lot of algebra. This one was very heavy algebra. Are there any questions on this one? Question? Yes, ma'am.
Will it be like this on the test? Like where there's like a lot of algebra?
There will be algebra on your test. Okay. So explain why there has to be some value r from 1 to 3 where h of r equals negative 5, and then explain why there has to be value c from 1 to 3 where h prime equals negative 5. If you're talking about function values, where does this function have to hit this function value? What theorem are you using? IVT. If you're talking about derivative values, what theorem are you using? MVT. So, does the function have to hit a certain value? That's IVT. Does the derivative have to hit a certain value? That's MVT. Some of you guys are using roles. Roles only applies if the derivative equals what? 0. That's it. So you can't use roles to justify a derivative equaling negative 5. It doesn't work. You have to use MVT for this guy, IVT for this guy. All right, so IVT. What's the first condition for IVT? It's continuous. So we need to show that H is continuous. Since F and G are both differentiable, that means F and G are both continuous. And since H is equal to F of G of X minus 6, then H is continuous. If these are both continuous, then H is continuous. So you could, however you wanted to word that, all I was looking for was, did you say H is continuous? So F and G are differentiable and therefore continuous. So H is continuous. And I'll let you could have just left it there because they said it is differentiable for all real numbers. But if you wanted to do on the closed interval, that was fine too. All right. The next check for IVT is you need to know if the value you're interested in is in between the endpoints. So you need to find h of 1, you need to find h of 3. H of 1 is f of g of 1 minus 6. All right, so when you do composition of functions, you do inside out. What is g of 1? 2. This is f of 2 minus 6. What is f of 2? 9 minus 6. H of 1 is 3. H of 3 is f of g of 3 minus 6. What's g of 3? 4. This is f of 4 minus 6. What's f of 4? Negative 1 minus 6. Negative 7. Does negative 5 fall in between those two? Yes. But be careful how you write this. H of 3 is less than or equal to negative 5, which is less than or equal to h of 1, and not the other way around. So you can't switch them. The higher endpoint was the lower number, so make sure you have them in the right order. Okay, check, check. IVT applies. Then you just write your conclusion statement. Therefore, name the theorem by name, or I don't accept the conclusion, by the IVT, and then you just rewrite the question. There must be a value R on 1 to 3 such that h of R equals negative 5. All right, MVT actually ends up being easier because you've done a lot of the work for MVT already. So MVT, what are the two conditions for MVT? H of x has to be what and what? Continuous and differentiable, right? So let's see, f and g are differentiable and therefore continuous. So h is both continuous and differentiable. All right, technically you're continuous on the closed interval, differentiable on the open interval, but it's really technically differentiable and continuous for all real numbers because they said that, so however, whatever interval you put would have been correct. So anyway, all right. So there's the first requirement for MVT. Some of you said, since MVT applies, therefore there must be a place where the slope is negative 5. The conclusion of MVT is not that the slope is negative 5. The conclusion of MVT is that the instantaneous or rate of change or the derivative has to equal the what? The average rate of change. So you got to check the average rate of change because if it's not negative 5, you can't say that the slope is negative 5. So we've got to find the average rate of change. So our average rate of change, so that would be h from 1 to 3. H of 3 minus h of 1 over 3 minus 1. H of 3 is negative 7. H of 1 is 3. So you end up with negative 10 over 2. Or, hey, look at that, it's negative 5. Yay! Okay, so then you write your conclusion statement. Therefore, by the MVT, there must be a value C in 1 to 3 such that f prime of C equals negative 5. Know your theorems. They will be on your test. Any questions on theorems? Yes, Mohit. From chapter 1 or 2? No. Good. Any other questions? Okay. All right, it's your favorite subject. L'Hopital. So, we ended up No, this one we kept. It's the next one that we dropped. This one was actually a pretty easy L'Hopital. All right. So when you plug in the 0, let's just think about this. You get 0, because the limit is x approaches 0 of x squared is 0. Cotangent of 0. Cotangent of 0. What does that approach? It approaches infinity. So you have a 0 times an infinity. 0 times infinity is not L'Hopital. You have to rewrite it. Personally, the easiest way to rewrite this by far was to just put the cotangent on the bottom and call it tangent. Or rewrite it in terms of sines and cosines. Much harder to put the x squared on the bottom. So the easiest way to approach this was to rewrite your limit as x squared over tan x. All right, so now, what's the tangent of 0? What's the tangent of 0? 0. So you have a 0 over 0. Now you can L'Hopital. You can only L'Hopital when you have 0 over 0 or infinity over infinity. 0 times infinity is not a L'Hopital. You have to rewrite it somehow. So 0 over 0 or infinity over infinity. But first we got to justify. So limit x approaches 0 from the right of x squared equals 0, which equals the limit x approaches 0 from the right tan x. Therefore, L'Hopital applies. Okay, so now we can L'Hopital. So, derivative of x squared is 2x. That's the derivative of tangent. Secant squared x. Plug in the 0 on top, you get 0. What is the secant of 0? What is the cosine of 0? 1. So what's the secant of 0? 1, because it's the reciprocal of cosine. 0 over 1 is 0. That's your answer. Done. 0 over 0 is bad. 0 over 1 is fine. All right.
So if it's 0 over 0,
You'd have to do another L'Hopital. Okay, I liked this one, but we dropped this from scoring. None of us, we didn't even look at it. So, which is why if you didn't lose points on number 6, that's why. Because Ms. Grunwald came in here, was it during this class or the next class? This class. And she's like, this problem is way too hard. And I'm like, well, I thought it was fair. And she's like, no, let's take a look at how your students are doing on it. And so she picks up every single quiz that had been turned in so far. Wrong, 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 wrong. I was 0 for 8. So she's like, I think we need to drop this from the scoring. So we dropped it from the scoring. But you guys should be able to do this. And I need to warn you, your test has a tough L'Hopital on it. So be ready to do a tough L'Hopital. All right. Although this morning, the students I was helping in the MRC, we were doing some of the review. There's some good L'Hopitals in your review on Web Assignment. So if you haven't done that review yet, you really should do that review. All right. Bless you. So, bless you. All right. So when we plug in a 1, we get a 0 to the 0. So 0 to the 0 means we still got it's indeterminate, but we have to do something. We need to get rid of that exponent, so we're going to have to take the natural log of both sides. So the first thing I'm going to do is set this whole thing equal to y. All right, so now I'm going to natural log both sides. So always keep your limit in front. So we have ln x comes in front times the natural log of x minus 1. All right, now if we do a limit, now we've got a 0 times an infinity, because as this approaches 0 from the right, natural log approaching 0 from the right is negative. Technically, it's a 0 times a negative infinity. So because of that, something's got to go to the bottom. So I put the ln x to the bottom. This one is kind of potato. Really doesn't matter which one goes to the bottom. All right, so I have a 1 over ln x on the bottom, and now I can justify my L'Hopital. This guy approaches negative infinity. This guy, as x approaches 1 from the right, the natural log of 1 from the right is positive. So this is going to positive infinity. So technically, you needed 2 separate limit justifications. The limit of the top goes to negative infinity. The limit of the bottom, of 1 over ln x goes to positive infinity. Therefore, L'Hopital applies. All right, let's do our L'Hopital. Derivative of the top, d, like u prime over u. So 1 over x minus 1. This is not u prime over u. Like it's 1 over. So think of this as of ln x to the negative first. So the derivative of ln x to the negative first is negative ln x to the negative second times the derivative of ln x, which is 1 over x. So what you end up with, I'm going to write it here. Let's just clean this up a little bit. 1 over x minus 1 over negative 1 over x times ln x squared. Okay, so ln y equals the limit, x approaches 1 from the right, of x times ln x quantity squared, and this would be negative over x minus 1. Now we plug in a 1 and we get 0 over 0. We get to L'Hopital again, right? Okay, so I'm going to write my justification over here. Negative x ln x squared equals 0. Limit of x minus 1. L'Hopital applies. Fun with derivatives. This is great because it forces you not only to understand your the graphs of your functions really well, so you know what it's approaching, right? It forces you to be able to do all these complicated derivatives. L'Hopitals are great problems. So so on top, what rule do we have to use? Product rule and chain, but yeah, product rule. So you have negative 1 times ln x quantity squared minus x times 2 times ln x to the first times the root of ln x, which is 1 over x, all over 1. All right, so if we clean this up, so we have this and this cancel. So we have negative ln x squared minus 2 ln x. All right, as x approaches 1, what's the natural log of x? 0. Natural log of 1 is 0. So we have ln y equals 0. So y equals e to the 0, which is 1, and that's our answer. I tell you now, there will be a difficult L'Hopital on your test. So if you're having a hard time with these, these take practice. They take practice for a lot of reasons. So make sure you know what justifies a L'Hopital, how all these graphs work as x approaches 0 or 1 or these funky numbers, right? Make sure you know all your derivatives, all this stuff. All right, any questions? Does anyone need me to back up and show anything? We're almost done, and which is good. We still have a half hour left. We're almost done. Okay. Come on. Come on, go away. All right. This one gave you guys a harder time, honestly gave you a harder time than I thought it would. I thought this problem would not be that difficult, but this problem was difficult for a lot of people. So we'll walk through this, and I'm hoping after you see it, you'll be like, oh, okay, it's really not that bad. So the top and bottom margins of a poster are 6 centimeters, and the side margins are 4 centimeters. So you have a poster with margins, right? So this margin is 6, this margin is 4, and then you've got this printed area in here. All right, if the area of the printed material is fixed at 384 centimeters, find the dimensions of the poster with the smallest area. And so several people came up and asked me, and I kept saying, it's the dimensions of the whole poster, So anyway, so the printed area is fixed. I personally, and you could have labeled X and Y as like your whole length, I let this distance be X, and I let this distance be Y. You could have done it with the whole thing and then subtracted. I like adding, so I went with the smaller X adding the margins and the smaller Y adding the margins instead of doing the bigger and subtracting the margins. You get the same answer either way. All right, so we are trying to find the dimensions of the poster with the smallest area. Is it really smallest area, not the biggest area? All right, smallest area. Remember, the first thing you always write with an optimization question is an equation for what you're trying to optimize. We're trying to optimize the area of the whole poster. So area is, width times height or whatever. So it would be X plus 8 times Y plus 12. If you did like the whole thing, X and Y would be X minus 8, Y minus 12. It's the same thing, just however you chose to label your figure. All right, so we have our area equation, our primary equation, except it's in terms of 2 variables, so we got to get rid of one. But we know that the fixed print area is 384. So we know that X times Y equals 384. Honestly, you can solve for either letter. It makes no difference. What do you want me to solve for? X. All right. So X equals 384 over Y. So we have area equals 384 over Y plus 8 times Y plus 12. Now, for the derivative, do you want me to multiply this out first and then differentiate, or do you want me to differentiate with product rule? Again, it's potato banana. Multiply it out first. Is that what you guys would have done? Okay. So our area equals, so we end up with 384, because the Y cancels, right? Plus 12 times 384 over Y, plus 8Y, plus 8 times 12, which is 96. All right. Notice I don't multiply out the 12 times 384. There's no need to. And a lot of times when you multiply out your numbers, you just end up dividing stuff out anyway, and so you've multiplied for nothing. So don't spend time multiplying multi-digit numbers together. You're just wasting your time. All right. So now we're going to do dA dy. That guy's gone. This is negative 12 times 384 y to the negative second, or over y squared, plus 8. We want to know where the derivative equals 0. What do I need to find? Well, I know I need to find y, but in order to find y, what do I need to find first? What's my second new favorite word? My first favorite word is factor. My second favorite word, which is actually an acronym for 3 words, it's what I'm going to have to find for this. Nobody knows. LCD. I have to find an LCD. Thank you. 12 times 384 plus 8y squared all over y. How else are you going to solve for it, right? You need the zeros on the top and the bottom. You got to have it as one big fraction. All right. Now, the bottom, if we set the bottom equal to 0, we get y equals 0, which wouldn't be much of a question, right? Okay, so let's just set the top equal to 0. So you get 8y squared equals 12 times 384. So y squared equals 12 times 384 over 8. Now we cancel. Life is easier when you can cancel. So divide by 4, you get 2. Divide by 4, you get 3. Divide by 2 here. And let's see, you get 192. So y squared equals 3 times 192. We need the square root of whatever 3 times 192 is. And it's actually easier if you kind of break your number up. So I don't know. I've seen some of you guys make factor trees. I know you know how to make them. Let's see. So this is 2 times 96. So 3 times 2 times 2 times 48. So 3 times 2 times 2 times 4 times 16. This isn't a perfect square? 3 times 16. I can do that. 3 times 16. There we go. 3 times 16. All right. Just breaking it apart enough so I can find the square root. All right. So the square root, so there's going to be a 3, a 2, and a 4. So 3 times 2 is 6 times 4 is 24. All right, so I get my y of 24. So that was a long time finding the square root of 3 times 192. It probably would have been easier if I actually just multiplied it out and figured out the square root. But anyway. All right, so I get a y of 24. X equals 384 over 24. Let's do some canceling. Divide by 4, you get 6. Divide by 4, you get 96. Oh, you can kill off a 6. Divide by 6. Divide by 6, and you get 116. So x is 16. All right. Except the area of my poster is not 16 by 24. The area of my poster is x plus 8 and y plus 12, the dimensions. So my dimensions are actually 16 plus dimensions. Oh, right, okay. Dimensions would be 16 plus 8 by 24 plus 12, or 24 by 36 centimeters. Yes.
Did that number not equal 384?
Does that what?
Did that number not have to equal 384?
The 384, it couldn't equal 384 because 384 was the area of the printed region without the margins. And we were trying to minimize the area of the whole poster. Good. Other questions? All right. Last problem, which takes 5 seconds. If you either knew it or you didn't. If g of 5 is 12, g prime of 5 is 0, and g double prime is negative 15, If x is the only critical number for g, identify all relative extrema. Justify your answer. Relative extrema have to occur at a what? Have to occur at a critical number. So x equals 5 is the only critical number, so that's our only relative max or min. So we're ready to write the answer. A rel something occurs at relative extrema. How do we write them? X values, y values, ordered pairs. Ordered pairs. So what's the ordered pair here? 5, 12. Whoops, I can write it 12. 12. Because, what test are we using? Second derivative test. So, first of all, let's go ahead and just answer the question. Is this a max or a min? Max. Because g prime of 5 equals 0. And please don't write g double prime of 5 as negative 15, because that makes it sound like your second derivative has to be negative 15 to have a relative max, and it doesn't. It just has to be negative. So don't write because g prime equals 0 and g double prime equals negative 15, because then I don't really know if you really know. So g prime equals 0 and g double prime is negative is your because statement for second derivative test for max. So, all right, that's it. That was that question. That was easy, 2 points if you knew your second derivative test. All right, we are done going through the entire big quiz. I'm stopping the recording.